Hey everybody, Matthew here from miniwargaming.com, and in this video I want to give you a complete guide to how to 3D print terrain. And I want to do it in as succinct as possible video, which is a challenge for me because I like to ramble. So much of a challenge that I'm going to take my phone and I'm going to hit start and I'm going to try to teach you everything you need to know within 15 to 20 minutes. But before I hit start, I want to point out two things. First off, this video is sponsored by Bamboo Labs. Bamboo Labs is kind enough to send us printers in exchange for sponsoring this entire series. Now you might think that that means that I'm biased towards my suggestions, especially once I tell you that you should buy a Bamboo Labs P1P, but I assure you that I would have told you that anyways because we love their printers so much. The second thing is I have an entire how to 3D print terrain course for free available right now at the link below. So while I will summarize everything in that course, if you want to get them in detail, then you can go and check out that course. It is designed for absolute beginners, much like this video. So let's jump right into it. How to 3D print terrain. Ready, set, go. First off, how do 3D printers work? There are two types of 3D printers. There are FDM printers and resin printers. We're going to talk about FDM printers here. Resin printers are used more for making miniatures, whereas FDM printers are primarily used in the miniature wargaming industry to make terrain, because they're not quite as detailed, but they are also a little cheaper to run given the material that you use. An FDM printer works by melting plastic. In this case, we're using polylactic acid plastic, which is PLA, and melts it and then lays it out layer by layer. It pulls it through an extruder and then through a hot end and then shoots it out a nozzle, which then lays it onto a build plate. In this case, we are using a textured build plate from Bamboo Labs, and which stays heated to keep the adherence of the plastic just slightly melted onto it, and builds it up layer by layer until you have a complete set of terrain or whatever it is that you're printing. That's really it. FDM printers, thankfully, are quite safe to use in your home, unlike resin printers where you have to take a lot of safety precautions. And for the most part, are, as long as you're printing with PLA and not some other materials, are not toxic. You might have to worry about the machine itself because it gets hot and there's also moving parts, so keep that away from pets and children. But other than that, they are quite safe to use. Next up, what do you need to buy in order to get into 3D printing terrain? Now this can be quite a long list, but to start, you only need a few things. First off is a 3D printer. Now there are tons of FDM printers out there, many of which are quite good, but many of which are a hot pile of garbage. I went through so many different types of printers on my quest of finding the perfect 3D printer. Now, I don't know if I found the perfect 3D printer, but I have found one that we like so much that I have 26 of them now in our print farm, and that is the Bamboo Labs P1P, and some of its similar types of printers like the X1 Carbon and the P1S and the A1 Mini. But for you, if you are wondering what printer to get and you don't want to do tons of research and you don't want to accidentally buy one that you have to spend tons of time and money on to repair and get the way you want, then please trust me and save yourself a lot of headaches and get a Bamboo Labs P1P. If you're looking at the other Bamboo Labs, the X1 Carbon or the P1S, for the most part, you're going to spend more money and not really get much more out of it because of what we are using it for, which is printing terrain. Now, you're also going to need some other materials. For example, you're going to need some PLA. PLA is the plastic that we melt and turn into terrain. There's a few brands that are pretty good. The ones I recommend are either from Bamboo Labs himself, or there's actually the one that we use a lot is the Elegoo Rapid PLA Plus. I'm going to put links below to all this stuff. It will be affiliate links, so I'll get a little bit of a percentage. But honestly, like I said, these are things that I would use anyways. You're also going to need some tools like clippers and paper towels, a scraper, and a wire brush, box cutter, just general stuff like that. And then you're going to want some IPA, some alcohol. It can actually be, in this case, just like rubbing alcohol, or it can be stuff that's way more pure. We use the 99.9% stuff because we also use it for resin stuff, which you need the stronger stuff for, because you use this to clean the build plate. But that's it. That's all you really need in order to get started. Once you have purchased your Bamboo Labs P1P printer, you are going to have to assemble it. Now, this is so easy. In fact, in the third part of my 3D printing course, I challenged myself to get the entire thing assembled within 15 minutes. And I was able to do so. And then just a few minutes later, after it runs some of its startup stuff and firmware updates, we were off to the races. Now, the Bambu Labs P1P printer comes with a really good instruction manual that walks you through all of the steps. So make sure you pay close attention to what you need to do. For example, there are some screws that must be unscrewed before you start the printer up, because those screws hold certain parts in place for shipping, but would be damaging if they were there when your printer was turned on. Please pay attention to the instructions and don't do things out of order. Don't pull parts out that you're not sure what they do. Just follow all the instructions and you will be up and running in no time. I remember the first time I put one together, I got it done in less than 20 minutes, and now I can do it in less than 15 because, well, actually I don't even put them together that often. So really it's just because of how easy they are to put together. Next up, you're gonna have to use what's called a slicer. A slicer is a piece of software that converts three-dimensional files. Usually we use STL files. So if you ever hear somebody talk about STLs, they're talking about the 3D files that we use to create this stuff. And it turns that into instructions for the printer. For example, the printer doesn't really know that something is three-dimensional. It's just told, move this over here, extrude plastic, move over there, back and forth, and it just keeps doing that until it is complete. The slicer is what does that. Now, it's called a slicer because it literally takes a three-dimensional file and it slices it into layers, because that is how things are printed, layer by layer, building upon the previous one until you have your piece of terrain or whatever it is that you're printing. We use, of course, the Bambu Studio slicer because that is what comes with the Bambu Labs printers, and it is awesome. It's perfectly fine for what we want to use here. It has all the options. You can go on their website and get it for free and install it onto your computer. There's also a Bambu software that goes on your phone so you can monitor your printers, but that's not actually what you use to slice. Once you're in your slicer, you just need to import your STLs. You can do this by just dragging the file into the Bambu Studio project file and then orient it the way that you want to and make sure it's ready to go, and then you can slice it. Now there's a couple settings that you want to use. There's so many settings, by the way, when you look at this that you can get easily overwhelmed and think, which of these do I need? 99% of them you can leave at the default. The ones that I would change would be the infill ratio. So in this case, we like 10%. The infill is how much of the solid areas will be plastic. Obviously, if you have some big piece of terrain and it just makes it solid plastic, that's going to use up way more material than you need and be way heavier than you need. So instead what it does is it creates like a grid-like pattern or like a honeycomb pattern, whichever one you choose, and it does only a certain percentage. We find that 10% is more than enough. That means 90% of the inside of the terrain is air, which saves you so much PLA. And you might think, well, that sounds like it's not going to be very strong. It is more than enough. You can go to 15% if you're worried about certain strengths, or even higher for small pieces, but honestly, 10% is just fine. The other one is looking at supports and brims, which of course will be more necessary depending on the type of file that you get. So let's talk about brims and supports. Now that we're in the slicer, we need to understand what they are and how to use them. Brims are an extra layer of plastic around the first layer. So if you're looking at it on the bottom layer and it's a circle, then a brim would just be a ring around that circle. What this does is it helps the first layer adhere properly to the bed plate, because I'm going to tell you that one of the number one problems you're going to have is the first layer failing because it fails to stick to the plate. Now we'll talk about how you can prevent that in a few minutes, but the first thing you can look at is maybe if it's a really small connection to the build plate, but it's a tall piece of terrain, that you'll want to turn on brims. Now in Bambu Studio, you just go to the support section and turn on brims, and you can just set it to outside brims only, and that'll be more than enough. Now supports are where you add in plastic because something is designed without really thinking about the limitations of a 3D printer. For example, if I were to hold my hand like this and say, let's print this, well, it can print this part just fine, layer on layer on layer, but once it gets here, if it tries to print and it goes up to here, the plastic is just going to droop and it's going to fail. So what we do is we add supports that print from the bottom all the way up and connect, then we then disconnect those afterwards so that it is able to print properly. Now, where do you need to use supports? If you turn on supports and then tell Bambu Studio to just add them wherever it thinks it needs them, it's going to add them in way more places than necessary. Essentially, you can look at the STL itself, look at the 3D file, and try to find any areas where the angle is more than 45 degrees. If it goes further than that, most likely it needs supports. Unless it's just going out a little bit from the side, then it's most likely okay. Sometimes it'll give you warnings as well, but you have to get to know where to add them. You could just print it and then see where it fails and add supports there, but that could waste you some time and a little bit of money too in the PLA. Now, whatever you do, when you go to put on supports, don't just do auto supports and be done with it. What you want to do are tree supports, and then you want to manually paint them on any problem areas. So you do that by selecting the drop down to Tree Manual, and then you can take the brush and paint the areas where you think you will need supports. This might seem overwhelming at first, and hopefully, for the most part, you don't need supports, which will go into our next area, talking about STLs and where to find good ones. But when you do need supports, then just remember, paint them on manually. Now, if all else fails, you could choose auto supports, but the problem is sometimes the supports will just be so everywhere that they can damage the model that you're trying to print, especially when you go to remove them. And they can just waste PLA. So look where you think you'll need them, add them in by manually painting them on, and your life will be much better. Next up is, where do you find good STLs? Because I can tell you that since there are so many 3D sculptors out there, that there are a lot of really bad 3D sculpts. I didn't realize this at first. I would go on My Mini Factory, which is a good place to go and find sculpts, and I found some beautiful renders, and I thought, that is gonna look so good. But I couldn't print them properly. They just failed over and over and over again. When I finally contacted one of these people and said, hey, do you know how I can do this? And they said, actually, I've never printed them before, so I'm not quite sure. That just blew my mind. They are selling 3D sculpts intended for you to 3D print them, but they've never tested them and seen that they're actually gonna work. So learning how to see if somebody can be trusted is a big part of it. One of the things you can look for, it's not always gonna be there, but you can look for this, is if they actually have printed samples in their store. So in other words, you can see the render, but they'll also have a picture of it already printed. If they have a picture of it already printed, chances are the STL is going to work. You can look at if they sell a lot of STLs. You can look at user reviews and what they say, if there are comments, and it can give you a pretty good idea. After a while, you'll get an eye for it. You'll be able to look at that and say, those parts are too thin, they're not gonna print really well, or that's way too much of an overhang, I'm gonna need tons of supports, and that's really not going to work. So you'll understand. Now, where to actually find good 3D sculpts? There are a lot of places, but the few that I recommend, number one would be My Mini Factory. It's great. It's designed primarily for miniature wargaming, so you'll find miniatures for the actual miniatures themselves that you'll want to do in resin, so not for this, and you'll also find plenty of terrain in there as well. There are other sites like Cults 3D, so cults3d.com. Once again, I'll put these links below. There's Thingiverse. There's one called Yegi, which actually is kind of a search engine of STLs. Speaking of which, Google is a great place because there are plenty of companies out there that don't sell on these different platforms. They only sell on their own site. Like, for example, Printable Scenery. They make some phenomenal terrain, but they don't really sell on all these different places. They only sell on their website. So you'd miss out on them if you only went to these STL stores. You want to find them separately. So Googling things like, hey, I want goblin ruins, or I don't know, medieval castles, 3D printable medieval castles on Google will help you find them as well. And then Maker World is one more specific to Bamboo Labs that you can use as well. Now let's jump into some common problems that you're going to have. I almost guarantee that you're going to have the first one of these, and then the second one, well, it might come up. So the first one is first layer bed adhesion failures. What this means is as it lays out that first layer, that it doesn't stick properly to the bed. Now this can be due to a lot of different factors. One is probably the most important, is that the bed is not clean. As you touch the bed, the oils from your hands will get on the bed. You might not even be able to see them, and they will obviously lubricate it, which is not a good way to have something stick to something else, because oils are primarily used to keep things from sticking to each other, which is the opposite of what we want with your first layer adhesion. So make sure you clean your plate on a regular basis. You can use alcohol to do this, just some IPA with a paper towel. Or if you're finding that you're having a hard time, I find that a good warm water and dish soap bath for your plate will be awesome for it, which you don't need to do very often, but every once in a while it's not a bad idea. The second reason that it might not adhere is because, like I said before, the file itself is so small on that first layer and maybe tall, and therefore once it gets higher, that leverage will cause it to fall off. You can fix this by adding brims, like we already talked about. Another reason that it might not adhere is because the build plate is starting to wear out. So we'll talk about maintenance in a second. If you've got a new printer, this shouldn't be an issue because you got a brand new build plate. Don't forget that the Bambu Labs build plates are double-sided. So if the one side does start to wear out, you can just flip it over. And lastly, of course, the STL itself might be garbage. I have downloaded STLs where the first layer was not flat. And that is obviously a big red flag for whoever did it, knowing what they're doing. Because like if you're gonna print something, that first layer better be flat, because if it's not, then how on earth is it going to print properly? Another common error that you're going to get is clogged nozzles. Now this can be caused because there's a lot of dust in the air, or maybe you're using cheap filament, or filament that's been sitting out a long time and has absorbed the moisture, or you might be using specialized filaments like silk filaments that give like a sheen, which are really fun to print with, but can gum up your nozzles. And sometimes it's just bad luck. Regular good filament might just get something in it and just gum up your nozzle. Now, to unclog a nozzle, there's a few ways that you can do this. One is just crank the temperature of the nozzle up to like 230 or 240 degrees and leave it, and that stuff might ooze out on its own. If that fails, then on the Bambu Labs P1P, you can take the plate or the front of the entire extruder off. You can unscrew these two screws right above the hot end, and then you can pull it out. And then you have a couple options here. You can once again turn up the nozzle to 220, 230 degrees. And then with an Allen key, you can push the plastic through and it should ooze out. For a bigger clog, what you could do is you can turn it up, do all the same steps, turn it up to the 220 to 230 degrees, and then take your Allen key again, heat up the Allen key and push it in slightly, and then wait for the entire thing to cool. What will happen is it'll actually fuse with your Allen key. And then once everything is totally cold, you do what's called a cold pull, where you just yank out the plastic even though it's solid, and that might crack it out and solve your problem. Between all of these, you should be able to unclog your nozzle without any issues. And that leads us to talking about maintenance of your printer. Now, overall, for maintenance of the Bambu Labs P1P, it's relatively straightforward. We have a lot of them, and we don't have to maintain them very often. But there are certain things that you definitely want to do. Most of them proactive, but some of them reactive as well. The most important one, or the most common one, I should say, is greasing the Z-axis or Z-axis screws. So they provide you with some lubricant grease, which you'll use. And every about 90 days, it'll have a warning pop up on your screen saying you should lubricate the Z-axis screws. And just do it. Don't ignore it, just do it. Also do it if you notice you can hear any sounds, like any little bit of grinding as it's going up and down. Now there are 3 of these screws, 2 in the front and then 1 in the middle of the back. So make sure you just get all 3 of them. You can buy more lubricant grease from Bambu Labs or from wherever you want. Just make sure you use the proper stuff. Another common thing that you're gonna have to do to maintain the printer is the build plate. Eventually the build plate does wear out. Now you can look for it wearing out for a few different ways. One, if you look at the plate itself, you might start to see some bald patches where the texture has worn off. If you look at the first layer of anything that you have printed, like these movement trays, for example, you can see the difference between a nicer build plate and one that's starting to wear out. The nice one has a nice even texture, whereas the one that's wearing out has different patches. Now, it doesn't mean you have to replace the textured build plate right away. It might print just fine depending on what you're trying to print. If it's something bigger, not usually an issue. It's the smaller the things get, the more likely they are to hit these bald areas, at least on the edges, and that can cause the edges to peel, which sometimes isn't a big deal, but can lead to things not being quite as high quality as it can be. Don't forget once again that there is 2 sides to each of these build plates. So if one side starts to get worn out, you can always flip it over. The other thing that you can do too, besides keeping it clean, is that you can start to apply glue to the build plate itself to make up for the fact that the texture isn't holding it in place quite as well. Bambu Labs actually provides some glue. You can buy some from their store. You can use a glue stick as well, just a regular school glue stick, but they tend to be a little bit more messy. than the one that Bambu Labs provides, but you totally can use that as well. But after a while, if you're finding that you have to glue things all the time, it's probably time to replace the build plate. It's not so expensive compared to the printer, and you only really have to do it if you're printing non-stop. You're looking at maybe every 6 months to a year that you have to replace it. The nozzle as well might need to be replaced, but we have found that they can last for years if you're only printing with PLA. If you start to print with more abrasive materials, you might find you have to change a little more often. But typically your nozzle can last a very long time, and you just have to declog it every once in a while. Now you might realize you have to change it if a couple of things happen. One, it is no longer the right shape. If you look at it straight on, instead of it being a circle, it's a bit oblong or like oval, then something's happened and you need to replace it. Or if you find that you declog it and it just keeps clogging quite frequently, you might want to replace the nozzle as well. It's not actually very hard to replace the nozzle. I'm not going to explain how to do it in this video because honestly, the manual and on Bambu Labs website shows you how to do it really straightforward. So just buy a replacement, you unscrew a few things, unplug a couple things, and then pop it right back in, reverse all of that, and Bob's your uncle. Another possible piece of maintenance you might have to do is the PTFE tube. This is the white tube that guides the PLA into the extruder. Now, if this is rubbing, so when your head is moving back and forth, you notice that the tube is always rubbing against a certain part of the printer, it can wear out because of that. They're pretty cheap, so replacing them is really not that expensive. Lastly, you are going to want to keep your printer clean. Depending on where you have it, whether it's in a workshop or in your home, it might be dusty. And so I'd say on a weekly basis, just take like a little Swiffer duster thing and dust the whole thing up, nice and easy. And every once in a while, if you're finding that you're having print failures, you might need to clean the fans. You can do this just by getting some compressed air, either from an airbrush or just one of those compressed air cans, and then just spraying it right into the fan, making the fan spin and hopefully shooting out any dust that it has. We've found that when we do that, then things can print way better. So just by keeping the printer clean and oiled and just well maintained, and that's really it. That's all you really have to worry about with these. Obviously, after years, it's going to start to break down because just like any other piece of machinery, and you'll have to do more maintenance. But if we're just talking for the near future, 6 months to a year, you really don't have a lot that you have to do. Not bad. My timer reads 22 minutes, but I also know that I paused a few times, so this video should be less than that, right? Right? Maybe? Either way, that is a complete guide to how to print 3D terrain. Now, or I should say how to 3D print terrain, whatever. We're gonna make the video a little longer here. Once again, links below. A lot of them are affiliate links. And also, if you want to get a more in-depth, detailed version of this, then please sign up for my course. It is 100% free. It's right there in the link below. Thanks so much for watching. Happy 3D printing.